Hi, and welcome to my video series of Biotechniques Explained in 5 minutes, where I explain a concept in biology in less than 5 minutes or so. If you haven't yet subscribed to my channel, hit that subscribe button, and please leave your comments below such that it gives me positive motivation to make more videos. Today's installment will be talking about 2D gel electrophoresis. As the name suggests, don't mistake it by thinking that 2D means like two dimension. Yeah, it is two-dimension gel electrophoresis, but here two-dimension means two parameters. So we already learned about SDS page, which we can tell as a one-dimension electrophoresis, or by saying that it's the separation is based on one parameter, and the first dimension is the separation based on molecular weight. Now, there are certain problems with one-dimensional gel electrophoresis. Let's say we in the last protocol in SDS page electrophoresis, what we did is like we stained the gel and we know our protein of interest is, let's say, 75 kilodalton, and we expect that our protein of interest to be present in that band. But imagine there could be other proteins which have very similar molecular weights, so our band which we are seeing at 75 kilodalton might not be a pure band of only one type of protein. It could be a complex band of having several type of proteins, right? So we need a second parameter which can resolve this issue and make the separation better, and that is why we can do a 2D gel electrophoresis. Now the two dimension of this 2D gel electrophoresis, which are basically two parameters, are isoelectric focusing, so separation based on isoelectric point, and second, separation based on molecular weight, just like the 1D gel electrophoresis. So what are the steps? Let's try to understand the process step by step and try to get the advantage of this. So in any protein sample, there could be proteins of several sizes, and also different type of proteins would have different degree of charges, right? So the separation would be on both the parameters. So let's talk about the isoelectric point first. So as we know, the isoelectric point is a particular pH point where the protein has no net mobility, and the mobility of the protein would be zero because protein would exist as a Zwitter ion. So the first step is to load the samples on an IPG strip, which is a gel having various pH gradients. So it has from cathode to from anode to cathode, it has a pH gradient, and once we run this gel, several proteins, as you can see in the screen, like the pink ones, the blue ones, and the yellow ones, which are having several different type of charge, would move and ultimately concentrate in format of a band. So what we have in the beginning is like several type of proteins of several sizes and several charges. So at the end of this isoelectric focusing, all the proteins with similar kind of isoelectric point would come together and concentrate in format of a band. Then what we can do is take this IPG strip and load it onto a second gel, and this is very similar to one dimension gel electrophoresis, and we would allow them to separate on basis of their molecular weight, and at the end what we get is a separation based on molecular weight. But we have two degrees of separation. One, we got in the vertical axis, we have the separation along the molecular weight, whereas in the horizontal axis we had the isoelectric point based separation. So the proteins which might have same molecular weight and concentrate in a format of a band in a one-dimensional gel electrophoresis, they might be easily separated in two-dimensional gel electrophoresis. For further analysis from this point, a spot on the two-dimensional gel can be dissected, taken out, purified, and we can run a mass spec on that for understanding better understanding its interactor or with its purity. I hope you enjoyed this video. If you like this video, give it a quick thumbs up. Don't forget to like, share, and subscribe.